Hello! In this video, we present the retrosynthesis of diazepam and lorazepam, taking advantage of the fact that both compounds share structural similarity. The differences are the methylated nitrogen in diazepam and the presence of a hydroxyl group and a chlorine attached to the phenyl in lorazepam. Starting with diazepams, a carbon-nitrogen disconnection produces lactam-3 as the first precursor and methyl iodide 4 as the raw material. On the other hand, in lorazepam, a carbon-oxygen disconnection based on an oxidation reaction of the alpha-methylene to a carbonyl generates lactam-5. Precursors 3 and 5 differ only in the presence of a chlorine atom attached to the phenyl in the case of lorazepam. This structural similarity allows unifying the retrosynthesis from intermediate 6. The disconnections and functional group transformations will be applied to the common structure 6, where the difference is the group X, which in the case of diazepam corresponds to a hydrogen atom, and in the case of lorazepam, to a chlorine atom. The imine present in 6 functions as a retron, as it can be formed by an intramolecular reaction between the amino and the carbonyl groups present in 7, generated by a carbon-nitrogen double bond disconnection. The amino group present in 7 can be obtained by a nucleophilic substitution of haloamide 8 and ammonia that arises as raw material. The amide group in 8 functions as a retron, and through a carbon-nitrogen disconnection, the substituted benzophenone 10 is obtained. And bromide or chloride of bromoacetyl or chloroacetyl 11 as raw materials. The carbonyl group present in 10 can be formed by the hydrolysis of the imine 12, obtained by a functional group transformation. The phenyl substituted with the group X can come from the nucleophilic addition to the cyano group present in 13 by the Grignard reagent 14, which in turn comes from bromobenzene 14. In the case of diazepam and orthochlorobromobenzene, in the case of lorazepam, the chlorine in para position to the amino group and meta to the cyano group can be introduced regioselectively by electrophilic aromatic chlorination. The amino group in 16 can be generated by reduction of the nitro group in 17 through functional group transformations. The cyano group in 17 is converted to the carboxylic acid in 18. And finally, this functional group is converted to a methyl. In this way, orthonitrotoluene 19 is obtained as the raw material. In summary, the main disconnections are shown here. In the following videos, the resulting syntheses of these two drugs will be presented.